So in the 10 minutes I have here, we're gonna try to program Pluto inside Pluto. Let's go. So let's just write some code over here. 2 can equals 2 plus can, I'm sorry. But what we care about is the expression object. So this colon at the beginning, it turns code into an expression object, which is a representation of Julia's syntax inside Julia, and Pluto relies on this heavily. So it has a head, that's the equality, so the assignment, I should say, and arguments, so the left and right hand side of the assignment. Now the left hand side is a symbol object, so token, and we can just turn it into a string like so. It's the representation of a variable name inside of a tree. And now for right hand side, as I said, it's a tree, so it's a nested expression object. So it also has a head. That's a call to a function, and that function is the first argument in this tree, so the plus, and the other arguments are, of course, the arguments to plus. So plus is a function in Julia. It's neat, and that's why it looks this way. So one thing you should know also for this is that we can use meta.parse on a string to actually get this expression tree out of a string. So this is the exact same expression object which you saw earlier. Okay, so we are going to need to know the references. So the variables that are referenced in a cell. So for example, for this 2 can equals 2 plus can, we would want to know that can is a variable which is referenced. So let's write a function for this. So our function is going to take an expression object, of type expression, and there's going to be 2 cases. One, if this expression assigns to something, then we only care about the right-hand side. So if the head is the assignment symbol, then we just care about args of 2, the right-hand side. Yep. And in the general case, so if it's not assigning to anything, we just care about everything. So we just descend down the syntax tree. So we go through all the arguments and one by one apply this function references to them. So this dot makes it do that, makes it applied one by one. And we take a union of sets because this function is going to return the set of symbols which are referenced in a cell. All right, we still need to define references for the leaf nodes in the tree, so the base case in our recursive function, so for a symbol. And of course, that's just going to be the set containing that symbol only. And we also need to know about values. So there's just going to be a general fallback case, which is going to be a value of just any type. And it's just going to be an empty set, of course, no symbols there. Yeah, so you can see that plus and can are referenced here, and that's correct. Plus is also used. Next, we need to know about the assignments, so the variables that a cell assigns to. So if can equals 3 is our cell, then we care about can. So we're also going to have an analogous function for that. It's also going to take an expression object, and it's going to have 2 cases as well. So if this expression is an assignment, so if the head is the assignment symbol, then what we do is we just care about the left-hand side, right? The symbol being assigned to, so that's just going to be a set containing only that symbol. So args of 1. And otherwise, well, there's no assignment happening, so we don't care about anything. That's just going to be an empty set of symbols. Yep. So let's just run this. Okay. Indeed, can is assigned to. That's cool. Now to figure out what cell should be ran before which one, we need to figure out the dependencies. So in this case, can should be ran before 2 can equals 2 plus can. So we're going to have a function depends on, and this one is going to take 2 strings, like 2 can equals 2 plus can and can equals 3. And yeah, let's write this function. So it should be true if the left argument, the first argument, depends on the second argument. So then the second argument should be ran first. Yeah, so this happens when any of the variables which are assigned to in the second argument are referenced in the first one. So any of the variables in assignments of cell B are referenced in cell A. And I'm going to let Parsing program this. All right, cool, you're almost done. So if, let's just test this. Yeah, indeed, it's true. 2 can equals 2 plus can depends on can equals 3, but it does not depend on cat equals 3. Yes, let's get going further on. So, well, now that we have this, we need to order the cells actually. So the Julia sort function is going to be convenient for this. Normally, if you were just sorting strings, you would get alphabetical order, but it lets us apply this LT argument, so less than, which is a comparison function. And now I got reverse order, I should invert this function. Yep. So indeed, can equals 3 should be ran first. We get the right order. Now we're going to need to test this, so we should put this in a function. Parsing, do this. Cool. Okay, we have a function run order, which is going to take just a list of cells, and it's going to return, yeah, just what we did here. So, well, we have the obvious tests, copy pasty. Yep. And let's start messing with it. So maybe let's add an independent cell, this cat, -1, let's say. Yeah, and let's maybe make it depend on toucan to see if it switches places. Yep, we got there. So it's executed last after both cells, which should be executed before it. Cool, so now we're going to need to be able to actually run a cell. So Julia also has a function for that, of course. So we're going to just make a quick wrapper. So run cell of cell, which is a string. That's just going to be asking Julia to run this, this code. And it's, of course, going to modify something, so that's why the exclamation mark is there. So the function for that is core eval, and the first argument which it takes is the module that this should be ran in. So main in this case, let's be trashy. Yep. So let's just test this quickly to see if it works. So this function is going to return the value which a cell evaluates to. And of course I missed the exclamation point. Let's do that. Okay, so indeed can equals 3, evaluates to 3. Nice. So now we should have a function to run multiple cells in correct order, and that's essentially Pluto. So let's just write that quickly. It's going to be simple. It's going to run each cell, so run cell dot, for each cell in the right order, right? So in the run, where we're going to take the cells in run order. Yep. And let's test this. So run cells of what we had copy pasted there. This should, oh right, this should miss an exclamation point. Yeah, okay, so we have 3 and 5, and let's see what these are. Well, I'm guessing as you expect, toucan is 5 and can is 3. Heyo! So let's see what happens to Pluto if we change stuff over here. Let's change can to be 4. Oopsie. I think I broke it. Alright, that's about it for me. I hope you liked my presentation. I hope you feel like you could have made Pluto yourself. And well, you actually can, right? It's open source on GitHub. You can contribute. Yeah, if you have any questions, I'm not actually sure how questions work in this conference, but I'm pretty sure you know by now, so just hit me up. Ciao!
All right, thank you so much, Nick. That was awesome. I didn't know you could make Pluto in 10 minutes. So for context, I started Pluto together with Nick, and he is the one who made Pluto reactive. So you can thank Nick every time that you don't have variables left around in your scope or something like this. I guess maybe my first question is like, say that we have a little army of Julia and JavaScript developers ready to work on Pluto. What would you like them to be working on next?
Yeah, so last time I knew, there was a thing on GitHub like good first issue and that sort of stuff, right? So you can look over there, and you can also look on our Notion page. Our Notion page contains a lot of stuff that we would really like to see, like dark mode. Yeah.
All right, thanks. Connor, you have any questions?
Yeah, so I guess a question of mine would be, you make this look so easy, and in other languages, right, this is, I guess, not something that's nearly as easy. So I guess I wanted to ask, what makes this look, maybe it's not so easy, but what makes it look so easy in Julia, I guess?
I mean, so one thing which made it look quite easy is the typing, right? So multiple dispatch, if you have Svadit, help, I need programming words. Yeah, so if you have a function and you specify what type it takes, you can define it multiple times, taking different types. And this really helped with handling the leaves over here. Yeah.
All right. I think that's it, and we'll go to our lunch break. If you'd like to get in touch with any of us, including Nick, send us an email, go to GitHub, go to Notion, blah, blah, blah. Okay, see you after the break.